Hello everyone, what is up? This is Christian from NetGuru. I'm the AI consulting lead, and today is Patrick, our R&D lead. Hello Patrick, how is
Hello.
everything going?
All good, thank you.
So far so good. All right, perfect. So it seems that this is actually our so far last episode of AI for Developers webinar. So if you still want to see some previous episodes, you can easily find them on LinkedIn. So yeah, and hopefully we will come back with something new. So we need only to figure this out, right? So yeah. So today we're going to explore the topic of visual novels with AI, right? So how to boost the creativity process of creating, let's say, content or even like specifically novels. So what it's all about? Can you tell me like what's the general idea of utilize AI to create such creation?
Yes. So today we are going to use some open source models, but not one, not two, but we'll use 4 different models. One really small to generate some stories, one big model to generate some prompts for another model about this story, stable diffusion to generate some images, and of course something for audio, because we don't want only like the text images, but we also want to create an audiobook. So to be honest, today we will combine a lot of knowledge from previous episodes, because we are talking about agents, AI assistants, how GPT engineer can code, and today we will use like all of this knowledge plus some new techniques, so we can connect 4 different models into one pipeline and create something cool.
Cool. Do you think that, of course, we are doing it a little bit for fun, and like from probably your experience and or your perspective is also like exploring some technologies and mixing them, but like do you find that this can be somehow utilized, like in a real world, like practically? Where do you find some applications potentially? Maybe not even like today, but in next couple of months potentially.
Yeah, I think there is a lot of opportunities for this, because, for example, let's take retail. If you have retail, we need to have some images, some text. Sometimes it's cool to have some audio describing the product to increase accessibility. So we can go really far with it, because we can take like information about the product, really like pure labels, key value. Then we can generate out of it some cool description. Based on this description, we can put the product into some AI generated landscapes,
Yeah.
and after that we can increase accessibility by making it read uh, using voice as
Yeah.
assistance.
All right, cool. All right, so let's jump into it. You mentioned 4 models that we can use today, or 3 models, how it will all work.
4 models, and I think we can start by
Okay,
showing all of them.
perfect.
So let me screen share my screen, and we will start coding in Python in a second. And this is like all of those models can be run in like 10, 15 lines, nothing more. So really minimum knowledge about Python is required. And I will describe everything, but let's start maybe with models. The first model is Tiny Stories. It's super small model, and it's based on some cool research, because the researchers said uh, they can create small model that can be specialized in only one thing, to create tiny stories, like one paragraph, few sentences. So these cool tiny stories were trained, and this is the model that is the output. So today we'll be using this one, and you can also read the tiny stories paper, because it's really cool usage of small language models and how to approach the topic of specialized AI.
Yeah. This is
So
super,
this one,
yeah.
yeah, go ahead.
So yeah, so what you're saying here is that because there's a tons of discussion around whether we should create like super big omni models, generalist ones, right, versus the smallest one for very, let's say, specific use cases. And this is the perfect example where you can have a smaller model, therefore the cheaper one, less computing power, I guess, to run it, right? And it may do the job for this specific use case.
Exactly. There are two approaches. Generalists create like big models, big servers, huge amount of data and everything. And it's also cool because if we have some generalized model, we can ask it about anything and it will work probably in every case. Sometimes we need something specialized, maybe smaller, like tiny stories, but sometimes we need something really big also, for example, for medicine, biology, to have specialized knowledge, but also be able to generally think logically, you know.
Mm-hmm.
So we have this tiny stories model, and this will create for us tiny stories that we'll see in a second. After that, we'll use a model from Microsoft. It's quite a big model,
Mm-hmm.
and it's considered large language model, but for its compared to others, it's really small.
So it's
But
a quite big for a small language models.
or quite small for large
Large
language
language
model.
models. Okay.
Yeah,
Okay.
the other way, because this is generalized model
Mm-hmm.
and it is used. This is generalized model and it is used for everything basically, and we'll use it to ask. We'll ask this model to create for us prompt for Stable Diffusion to generate image about the previous story. So, for example, if we have story about some, I don't know, knights with castle, with swords in the castle. So this model will take the story and generate image, for example, a knight on a horse and the castle in the background, So this is the bigger model that we'll use. And after that, we'll go to this model. This is
Mm-hmm.
pretty old model, SDXL Lighting. And why we are using this one specifically? Because this one is really fast. It creates
Mm-hmm.
high quality images, but using only like 1, 2, 4, or 8 steps. So
Mm-hmm.
the generation is pretty fast because in classic Stable Diffusion, we need like 20 steps. And if we think about one step, it's like, I don't know, 5 to 10 seconds. So using 20 steps, we have like 200 seconds. So it's quite long. But here is specialized model that is trained to only do 1, 2, or 4 steps, to be
Mm-hmm.
really, really fast.
Mm-hmm. So this is like they literally saying they distilled, right, from regular Stable Diffusion. All right.
Yes, it's like the packed version to
Mm-hmm.
output something really fast, maybe not so reliably, really. You cannot be always sure that you get what you want in this
Yeah,
case.
yeah. I guess that it will be even more random that regular model probably, right? And you may have a less control over the output, but as you mentioned, the responsiveness and how fast it can go, right, is the number one priority here.
Exactly, because during distilling the models, so making bigger models smaller, we need to cut some data. So
Mm-hmm.
it's smaller, it was cut in some places, so it might not have all of the information necessary to recreate the images.
Right.
So yeah, and maybe let me mention about these steps. What does it mean even? The Stable Diffusion always starts from the noise. So you get like some random pixels, and each step is making the image closer to the description. So if we ask about cat, we start with random noise. Then we have step 1. So for example, it's adding the black circle in the middle. Then in step 2, it's adding, like maybe ears, some, tail or something. And in each steps, it's making like more accurate, more stable, I would say.
Mm-hmm.
Yeah. Okay, and finally, we need to create an audio because we have text, we have some images. We will use
Mhm.
whisper speech. You probably recognize the whisper.
Yeah, of course, of course. So this is the text to speech model that we've been using a lot, right? To
Yes,
generate audio
speech to
files.
text.
Yeah.
This
Speech
is
to
the
text. Yeah.
speech to text. It's from OpenAI, the Whisper, and it allows you to basically take audio and make transcriptions of it. And this is like reversed version of it.
Mm-hmm.
So here we have like you have some text and you need to create audio.
Right.
So it's also really cool and it's on GitHub, this model, but probably you can find it on Hugging Face. But I use GitHub because there's a lot of examples and it's constantly updated. So it's really cool to follow it here. Perfect. So we'll use those four models.
All right.
And
So we're using like a step-by-step process up from initially transforming the text, generating the text, transforming the text, generating images, up to uh, text-to-speech generation. All
exactly.
right.
Exactly. And here we are using some base models that we can run on our computer. So these are small, so the outcome is not so incredible. You will probably need to use, like, for example, some state-of-the-art, Llama if you want something open source, maybe GPT from OpenAI to have state-of-the-art in commercial
Mm-hmm.
models. The same with, for example, stable diffusion. You can find like really cool commercial models that are generating really great images. But today we will start small and we can build up from this place. So mm, let's start with the code. We will start with generating the story. And how even I came out with this code? This is the main question here, I think. So if you go to the Hugging Face and these tiny stories, the model you want to use, almost always you have some example usage. And as you can see, you can just copy paste this, and I pasted it here, and this is the same. So we
Mm-hmm.
are using these transformers, model and tokenizer, using tiny stories with some input, output, and output text. So let's take a look here. We have our import, we have model tokenizer, we have input, output, and output text. So this is exactly the same code from the example. And all you need to change is this line. So
Mm-hmm.
I decided to go with a dragon topic, fantasy, So there
Yeah.
was a dragon named Patrick and Mighty Knight, Sir Tomasz, and
Mm-hmm.
we will see what the model will generate. This prompt will be taken here to the tokenizer, so it will transform this text to something that computer can understand. Then this computer text, let's call it, will go to the model that will generate for us um, final text with maximum length of 1000
Mm-hmm.
characters, tokens in this case, I think. And then we'll take output text and save it to our output.txt file to
Mm-hmm.
make it simple. So I won't run it because I ran it uh, before our live stream to save
Mm-hmm.
some time because it takes some time to load everything to memory, then it needs to generate, then drop the memory, and it takes time. So let's take a look at the output. So there was a dragon named Patrick and mighty knight Sir Tomasz. Lived in the cave near the forest. One day he decided to go for a walk in the forest, and so on. And this is the output from the Tiny Stories model.
Tiny stories. Okay.
Exactly. It's not maybe the best, but as you can see, it's specialized model and it picked up the job without even saying, you are a storyteller. Your job is
Yeah.
to write tiny story for this and that. Here we can just say like there was a dragon, like make a starting point, and it will generate for us the rest without even need to create like this prompt engineering stuff, because it's specialized model. It knows right from the start what to do.
Yeah, and this is basically created on your own machine, right? So this is the other thing.
Yeah, exactly. So everything is running locally. So you can, you just write Python space main.py, and it's running these 15 lines of code, and it's generating this text, and it's pretty cool. Maybe it's not consist because some names were changed, but it's still good, I think. Okay, so we have the text from the tiny story. So what to do next? Let me comment this, and let's go a little bit further here. So we'll use another model, and this model will be this generalized model that is pretty large, because we want to get because we want to take this text and convert it to some prompt to create image. So if we go to this example with Pito, let me go further. We have some sample code. So we just copy paste everything. We go to our editor and we paste it here. And I'm using MacBook, so I needed to comment this line because it's using CUDA, and CUDA is NVIDIA technology that we don't have in the Mac. So we have the model, we use the Microsoft version. There is one thing, there is storage dtype. I changed it to float 32 because in MacBooks float 16 is not working, but it's the minor stuff that you may encounter, but nothing to worry about. And then we go like the same path like before, input, output, and we have output text. So we have input, output, and text. So for the input, we use tokenizer like previously to change the text, human text, to computer text. Here I have some old something from old testing, and here we can specify, create a prompt for stable diffusion based on following text, and you can just add, the text from previous output. So we have output text, and then you pass these inputs to the model. We generate maximum 300 tokens because the stable diffusion models are limited in input. So we need something pretty short. And this is the huge difference, because as you can see here in the prompt, we need to specify what it needs to do. Because it's generalized model, you need to ask the model to, for example, create a prompt for stable diffusion. In previous model that was specialized, you didn't have to say anything. And in this case, you need to create some prompt engineering. So create a prompt for stable diffusion based on following text.
So actually, the previous one was specialized, and in this one, you need to, as in any regular LLM, you need to say what kind of output are you expecting, right? So this is why you're using this prompt.
Exactly. You can always like create your own model that will be specialized in creating stable diffusion prompts based on some text. And probably there are some, but to be honest, I don't know any model like this. So I decided to use some general model that is small enough to run on my machine and be able to create. So if we create this, we'll get, I'm not sure have I written the output, but if we run this and we print the text, we'll have like, the castle dot knight on a horse or something. And then we can go further to stable diffusion. And with stable diffusion, we have this one, up to this one. Oh, And here we have also the output. So it generated here information. A medieval trading caravan with a lot of boxes, a castle in the background, digital art, painting, pastel colors. This is the output from our previous model that was generalized to create prompts.
Okay, yeah, that totally makes sense. So the
Yeah,
previous model actually enriched the original kind of and condense original information into something that will be more usable for stable diffusion.
exactly. That was the goal. And now we can go with image generation. So let's go to the SDXL lighting. We can see some beautiful images. And if we scroll down a little, we have different examples. So we can basically pick the first one, I think. Yeah, so let's go. We can just copy paste everything as always. We go back to our code, and this is the same. So we have some stable diffusion. I'm using 8 steps to generate it. These are like loading the model, making it like easy to use, and then we add our prompt, and then we generate. For example, let me go to the output, and we get this image, which is quite good, I would say. We wanted a medieval caravan. We have some horses. We wanted a castle in the background, and
Yeah,
here we
it's
go.
kind of it's kind of even like medieval style sketch type of book in like old
Yeah,
medieval
exactly.
style. Yeah,
Like from some manuscript or something.
yeah.
Yes.
Exactly.
And the best thing, because up to this point, we could, like uncomment everything, run one command, and each model is feeding to one another. It's saving the files. So if you run it, you will get like the text, you will get the image itself, and you don't need any manual work besides like running everything. So it's also a different approach than using agents, because agents you ask to do something and they trying to figure it out. Here we have like our system where we run a command. For example, we could also specify like in the first step the prompt for the story, how it should start, and then everything is like made in the background.
So this is like triggering a snowball or a chain, let's say, of uh, other models that will step by step produce some output that will be actual input for the other model, right? So this is like a step by step almost.
Exactly. Uh, we call it pipeline. So we create a pipe, and basically all the data from different models are going to another through the pipes, let's say. It's pretty easy to visualize how it works.
Yeah.
Okay. And we have the image, which was also really simple because some copy pasting. And the last thing is even shorter because we have only a few lines. So we'll use this whisper speech, also with the pipeline, as always. We'll use the model, and we'll open the file that we saved before, so this one. And we want to create a file. And here is some cool thing, because it will be boring to have this, computer voice reading something. So using the whisper speech, we can specify, for example, a speaker voice, and it will try to clone the voice, for example, my voice, to the proper output. So let's maybe hear what I prepared as an input. It's me for 5 minutes reading an article from the internet about mathematics. So I just sit down, open the recording session, start talking, reading basically the article, then I stop. So let's hear the result of it.
Academic voice. Our publications follow what we call academic voice. We follow a largely academic style in our writing, but avoid certain academic tendencies. Academic style. Make no claims without support. If you have made an assumption.
Yes, and this is me talking, just reading some article from the internet. So we have our voice that we want to clone. Then we specify the text that we want to clone and where to save it. So for me, it's like the output. So maybe let's see the output. reading me the story generated by AI using AI voice that was cloned from my original one. So let's start.
There was a dragon named Patrick. Mighty knight Sir Tomasz lived in a cave near the forest. One day, he decided to go for a walk in the forest. As he was walking, he heard a loud noise. He looked around and
What do you think, Christian? Maybe it's not the best.
Yeah, probably it's still kind of robotic type voice a little bit, right?
Exactly. Um, I was doing this workshop few months ago once, and I have all the technology back from few months. But if you take a look, for example, today for on 11 Labs, for example,
Mm-hmm.
it's a Polish company that is doing like voice cloning and everything. They are creating really, really good quality voices
Mm-hmm.
from really small samples. So technology is advancing, and even I have one example somewhere where I fine-tuned the model. So this was the cloning of the voice using, like small sample, you put it, and then you can generate. But you can also specialize the model, like open source model, take like robotic voice and specialize it with, for example, like 30 minutes of you speaking directly
Mm-hmm.
to the model. And the model will pick up everything what you said and how you said it, and then you can create like good quality voice examples.
Mm-hmm. Wow, amazing.
Perfect. Yeah. So in less than 30 minutes, I think we used like four different models:
Mm-hmm.
small language model, large language model. We used stable diffusion for image generation, and we used whisper speech for audio generation. So as you can see, it's really easy today to use all the models. It's like few lines of code. They are mostly in the examples. You just copy, paste, and it works. It's so high level definition of coding that it almost requires no specialized knowledge about running the models or anything. As you can see here, we never go deeper than creating the input, output, and output text. So
Mm-hmm.
like three-step scenario in each case.
Yeah, this is amazing. And like for me, even like more impactful is that first of all, we've used local, right, solutions only. So this is like you can use that on and test it on your local machine. So this is the first thing. And second thing, as you mentioned, creating those pipelines of models where the output of one model is basically the input of the next model, and then you are getting the actual final output, which might be uh, quite amazing because this is like times per amount of previous models that you had. So yeah, and at the end of the day, very practical use case that could be potentially utilized in even like education type of business cases, of course any type of content creation. So yeah, very practical from my perspective. And since we see that more and more kind of educational companies are looking for AI innovations, that it might become very practical one day.
Yes, it will impact like all the industries where some content is created. With retail, you can create product-based, as I mentioned, content. In education, as you mentioned, you can create, I don't know, textbooks with images. You can add, for example, dialogues for language learning really easily using the
Yeah.
voice cloning techniques and everything. You can have few specialized people taking care of it instead of the whole team that is, doing everything. And probably some other everywhere where you have to generate some content. Maybe in
Yeah.
the future, Christian, we will clone our voices and let AI run these workshops.
Yeah, that would be that would be great. Maybe we can maybe try it next time. So yeah, definitely. And what you mentioned about also like transforming one content to the other, this is very practical use case because there are some companies that are having today like an ebooks or I don't know online courses, right, with some types of content, and with this technology or this type of technology, they can enhance this content and basically transform it into some other piece, either podcast or ebook, as you mentioned, or both, like visual and audio form, which can be even more immersive, right, for some use cases. So yeah, like quite amazing. And you can, as you mentioned, do all of that like at home and get, let's say, a decent result. So I guess if you would use, you mentioned 11 labs and have a little bit more cloud computing power and more advanced model, then the actual quality can be quite amazing.
Exactly. Here we spend like 30 minutes using like, locally running models. If we have some more time to, prepare, test every model, pick the best one that is generating the most cool stories, let's say, we'll use like bigger models to generate images, better fine-tuned models for voice, using like some servers, more computing power. It will get much better results. But I would say to start in 30 minutes, we reach pretty high level of quality for 30 minutes of work.
Yeah, and still, I think that even in this case, it really makes sense to use local models, because there are many companies that maybe would like to use quite similar use case for their proprietary content, right, or information that they have. And even like personally, like for workshops or training companies, this is kind of their own knowledge that they may not want to share with some external cloud providers, right? So in this case, probably a little bit more coding, right? More computing power for more like even better output, but it really makes sense to do it in this very direction, right? So yeah.
Exactly.
All right, thank you
I
very
think
much. But yeah.
Yeah. I just want to say that's all what I wanted to show you today.
All right, perfect. Thank you very much. It was super interesting. All those episodes, like, was super interesting. We're getting a lot of amazing feedback about it. So yeah, again, thank you very much for sharing, all your practical expertise and knowledge. Let's continue with some, other amazing stuff. And yeah, thank you all. If you all have any questions, feel free to contact us via LinkedIn or comments below this episode, and hopefully see you next time. Thanks a lot.
Thank you. Bye-bye.
Bye-bye.